Hey folks, welcome back to Mark Kelly Farm. And if you've never been here before, we have a little homestead here in Nebraska, and we do all things homestead, including recipes and gardening and shop projects and stuff like that. Today we're going to be doing a shop project, and let me show you what we're up to out here. Now our driveway out here is a gravel driveway. It's really fine gravel that they use here in Nebraska for just about everything. And we have to use loads of weed spray to keep the weeds from encroaching on our gravel driveway out here, because I like to keep it fairly clean. This driveway wasn't near as big when we first bought the homestead here. The grass had grown in pretty far. But we did a lot of weed spraying last year, and we've done a lot of weed spraying this year. And I don't like playing with the chemicals all the time, so we're going to figure out something different for our driveway. Now in the past, we have done several things. We have a landscape rake that, or rock rake, however some people call it, that we used out on the driveway, and we would just run circles out there and keep going until all the weeds were tore up in the driveway. Problem is that moved a lot of the gravel around too, and with the tines on the rock rake or the landscape rake are wide enough apart where sometimes the weeds get through those tines, and we don't get 100% of them. And because we move a lot of gravel around when we do that, then I would have to bring the box blade out and smooth all that back out again. So we've come up with a different idea that we're going to try now, that we're going to build an implement for. We're going to make like a giant hoe for the 3-point on our tractor. So let me give you kind of an idea what we have going on. So we've bought some steel to make us an implement, and this is some blade material that I purchased. Anybody in the metal business will call this grater bit, because you can see it's got this tapered edge on it. And this is what they use how to make blades on grater blades for road graders and even different implements, buckets and such. It's your actually cutting edge of your implement. So we've got a piece of that. We've got some drop pieces that we were able to purchase from the local metal supply place. This is leftover pieces from some other project that they had cut out with their plasma cutter. So we bought 4 of those. And then I bought a big heavy wall square tube for my toolbar. And what we're going to make with this is we're going to make something that glides along and just barely cuts the top edge of the driveway, knocking those weeds out of the driveway. And the dirt will be able to flow right over the top of that blade and not make a big mess and move a bunch of dirt around. So we'll get this project going, and you'll see it take shape, and you'll figure out by the end of this what this is going to look like. So we've got this 3-point A-frame that I got from a friend of mine here locally. He just gave it to me because it was laying around in his yard. They don't use them too much for the type of farming they do around here. This is more of a small-scale farming type operation. But what this A-frame does, it's the A-frame, toolbar A-frame, that big piece of square tubing that we call the toolbar, goes through these clamps, usually about as wide as the tractor or a little wider. And then on that toolbar you can clamp different implements. You can do cultivation sweeps, you can do hiller attachments, whatever you want to use. And there's clamps that actually go on the toolbar that those shanks or other things go through that you can tighten up. But we've got this. We're going to have to do some work to this before we can put it to use. These clamps here, the clamp bolts were cut off with a torch, probably because they couldn't get the nuts off or they were seized. So they just cut them. And this bolt swivels on this pin right here to open this clamp, like this one over here. This clamp opens up and you can put your toolbar in there, put it back down, you swing that bolt up, and then you tighten it up to clamp down on your bar. So we're going to have to fix these bolts. We'll pull the pins out. If we can't get them out, we'll cut those bolts off as well. We'll put new bolts in, but we need to fix these bolts right here so we can use these clamps again. The other thing we need to do is I have some shims that turn this Cat 1 pin into a Cat 2, and we also had to adjust our top link on our quick hitch to engage the top link on the A-frame. This A-frame is not quick hitch compatible, but it doesn't mean you can't use it. All you do is put a pin through here. You just rotate your A-frame up and shove a pin in it. You can still use it. But what I'll eventually do is I'll cut these ears off and I'll raise them up so the quick hitch can come in and hook, because I had to lower this hook to get it to work on this A-frame. It's lower than all my other attachments. So if I raise the pin point up, this quick hitch will be able to come in and I'll still be able to use it. But until now, this works fine. If your thing isn't quick hitch compatible, it'll still work. Now the other thing I'm going to do is I'm tired of messing with these bolts, so I bought pins to go in here. So this is a lot faster to adjust this here. So let's get some of that going. All right, we've got our bushings put in there. It just slides right over that pin, and then you put your linch pin back on here. And I leave these on my implement, so I'm never having to switch them around. And we got that put in on both sides. What that does, if you leave the small pin, it causes too much play in here, and there's too much play when you're using your implement. And sometimes it even works its way out of that hitch. I've had that happen on my landscape rake before I put the shims on it. So we got those on. Now we're going to replace these bolts right here. All right, we got those bolts replaced. This is going to make life much easier. These are just 5/8 pins. And then we use a 1/4 inch linch pin over here, which is smaller than your standard. I believe these are 5/16 or 3/8 down here. And if you didn't know, most tractors have this little loop on the lift arm where you can put your extra linch pins. But I keep linch pins on all my implements also, because I don't like looking for that stuff. So never have to go find that stuff. Now this pin here, I also have a bushing for this. But because of this lip hitting my quick hitch here, it's already tight in the quick hitch. But when I remedy this issue here by putting the larger ears on here, I'll have to put the bushing in here, and what I'll do is I'll just bolt it in, because once it's quick hitch compatible, this pin doesn't have to come out. So now what I'm going to do is I'm going to work on getting these clamp bolts out, and then the square hole here for our toolbar is 2 1/4 inches, and our toolbar that we bought is 2 1/2 inches. So what I'm going to do is I'm going to cut a 1/4 inch off the bottom of this to let the toolbar sit down in there further, so these clamps will come down. But we got to make sure we don't get this hole too big to where the toolbar wobbles in there. We need to make sure that there's still a gap in here when we get done. So once we clamp that, it'll put pressure on that toolbar when we secure it in place, and that'll keep it from moving around. So I'm going to get a hammer and beat these around, and we'll pull these bolts out, and then we can get to work on getting the toolbar in here. All right, we got this bolt loose. It was fairly tight, but we got our cordless Ryobi impact on it. That was my Christmas present to myself this year. It's the highest torque impact that Ryobi makes. They came out with it late last year, I believe. This one over here, however, wouldn't budge. I even tried my air impact on it, which probably doesn't have any more torque than that one does. So put some Aerocroil on it. If you've never used that, that stuff is amazing. It breaks everything loose. So we're going to let that soak in just for a little bit. I'm going to go get my 1/2 inch breaker bar and see if we can knock that loose. Well, with the 1/2 inch breaker bar, we succeeded in breaking that bolt off, which we were going to replace that bolt anyway, so that does not matter. So we'll drive this bolt out of here, and we'll get those clamps loose. So with a little help from my persuader tool here, we were able to get those bolts out and then get these pins out. that go in here, and that rotates. So I don't have any bolts this size. These are 7/8 bolts. So next time I go into town, I'll buy me some either 7/8 or 3/4 bolts. And what I'll do is I'll cut the heads off the bolts, and I'll use this eye portion here. We'll cut these off right here and stand these up real well. And then we'll take the ends of those bolts and we'll weld them to these eyes. Leave a nice V gap in here so we get a real good connection. We'll polish it up real nice, and these will be fixed. And then all we'll have to do is put a lock washer and a nut, probably a flat washer here, so we can tighten this toolbar clamp down to the toolbar. So what we're going to do now is we're going to go cut our toolbar to length because it's a little long to work with out here. And I'm going to cut it a little bit wider than the tires, maybe about 2 inches from the outside of the tire, because I want to see the edge of it. So when I'm doing a nice cut on the edge of the driveway between the grass and the driveway, I can look in my rear view mirrors and see the edge of that blade, so I can control it real well and steer the tractor so I can keep a nice clean edge. So I'm going to go cut the toolbar. So we measured outside to outside on our rear tires on the tractor. We ended up with 57 inches. 5 foot is 60 inches. So adding 6 inches to that will be 5 foot 3 inches. So we've got our metal cutting bandsaw. If you remember, we refurbed this thing after we got it at an auction. So we're going to use it. Don't mind all the June bugs on the floor in here. So because this is heavy wall tubing, you don't want to cut this with like an abrasive saw because it'll take forever and you'll heat up your saw blade. It gets a little dangerous because sometimes those saw blades will disintegrate on you. So the metal cutting bandsaw is pretty much the way to go on these. You could use a 4.5 inch grinder, but you're going to go through probably a couple discs trying to cut that. I need to make me a roller stand that I can put out and use with this bandsaw. I had to kind of jerry rig it over there, but we got it. We got her cut. This is actually the drop piece. This isn't the piece we're using, but our drop piece is long enough to where when I want to make my hiller attachment later, we'll buy the toolbar clamps. One will go right here, one will go right here, and then the hiller attachment will go through there. And then this is wide enough to fit in our A-frame to where we can make that hiller attachment. So rather than bring the big tube over here to adjust this clamp, I'm going to work with this smaller tube because it'll be a lot easier. You can see here on the end, because the tube sits up so high, this is a little bit bigger tube, that we don't have the clearance for the clamp to close. So as we notch out the bottom, that should allow this clamp to come down. That's our hopes anyway. So what we did here, you can see we got lines marked down at 1/4 inch. I got a piece of 1/4 inch thick angle iron, and we put it up against here, leaving it flush on the top right there. And then we draw a line underneath. That way we make sure that notch is perfectly 90 degrees, which is what this angle iron is. If we were to mark those individually, we might get a little bit off. But now we're going to come through probably with the plasma cutter and cut that. And then we'll probably just come straight down from here and connect it right there. And that should give us the clearance that we need. Now when we cut this, we're going to stay on top of the line. We're not going to cut the line off because we don't want to get any deeper. If we get any deeper, we might not be able to bring this clamp down all the way to fully clamp. So we don't want this loose. We're going to use our plasma cutter to cut these out. And because we have a piece of material on the other side over here, it's going to want to throw sparks. So make sure everything's well protected. You got to wear dark, tight-fitting glasses. Protect your eyes. So we're going to get after this. We got our heavy gloves out. We've got this side cut. You can see where we left the line. And when we close the clamp, we got about a 1/4 inch in here, which is perfect because when we get this bolt remanufactured, this clamp is going to squeeze that tube nice and tight. And that's what we want. We don't want that tube rotating in that clamp. So we're going to get the other side cut, and then that part of this operation will be complete. We got both sides cut, and we have the same clearance on this side, which we're real happy about. When I was knocking a piece of that cut piece off, I forgot my glove had a hole in the thumb, and I branded the end of my thumb. A little warm. So what we need to start thinking about now is our vertical pieces, and these are 3/8 of an inch thick. We need to figure out how long I want to make these. I don't want to make these too long because then that gives you a lot of play this way for it to bend around. So I want to keep it as short as I can because our blade is not going to be digging very far in the ground. Maybe an inch at the most if I set it that deep. So I need to take the tractor out where it's nice and level out in the driveway, lower that A-frame down, and see how long we need to make these. So that's drop dead bottom on our 3-point right there. But I don't necessarily want to run it that low. I want to come up a little bit, so if I have to go a little deeper, I can. So I'm probably going to raise this up maybe 4 to 6 inches, and then I'll measure the end of our toolbar to the ground to figure out how long those pieces need to be. So we figured out from the bottom corner of our toolbar, which is a 90-degree corner, to the top of the blade needs to be 12 inches. So let's go take a look at our uprights. So we've measured everything out. I've got a little scrap piece of our tubing. I think what we're going to do is we're going to cut a square out of this piece so it actually slides over the tube, and then we'll weld it all the way around. That'll give it a little bit of extra rigidity. And then I measured 12 inches from here to here, and that'll be a cut where our blade right here is going to weld. We have 3 inches of welding surface, and this just happens to be 3 inches across right here. Now this angle is probably going to have to change. We're probably going to have to come over to here to make our blade flat. What I'll do is we'll take this off, and then I'll run a straight edge from this corner to this corner all the way down, and then we'll go 90 degrees off of that straight edge, and that'll put us fairly vertical on the A-frame. And then any adjustments we need to make, we can do with the top link of the tractor to make the blade either cut more or less. So we'll make a pattern out of one of these, and then we'll duplicate it with all the others to get 4 of these. So we eyeballed what our corners were, we made a mark, and we put that on there, lined our straight edge up with those marks, and then we made 90 degrees off of the straight edge. So this is going to be our actual angle right here. And let's see how wide that is at that point. Is just a little over 3 inches. That's not going to hurt anything. So we're going to get this one cut out and then make a pattern. Now if you've never seen one of these pencils before, they're very handy. They're for marking metal, and you can get a lot better line than you can with like a soapstone or something like that. And it seems to last a little bit longer than soapstone, and you just sharpen it. It's pretty cool. I found these right out of high school, and we started using these. There's our pattern all made, and we got our angle pretty good. I'm going to drop that down a little bit, and we'll see how it looks. So it looks like we're spot on where we need to be. So we just need to make 3 more of those. All right, we got all of our 3 other pieces marked. They line up really well because they were all cut on a computerized plasma, so as long as you flush all the edges all the way around, you've got your pattern. So we're going to cut these other 3 out. I'm cleaning them up as I go, so I don't have to do that later. And then once we get this done, we can start welding. All right, we got them all cut. We just freehanded them out with the plasma cutter. Got all of them cut. So now we're going to clean them up with our little flapper wheel. And I don't recommend cutting things wearing Crocs and socks. You know, we say here at Mark Kelly Farm, safety third. All right, we've picked the 2 brackets that are the most closely matched together. There's always going to be some little subtle differences, but these 2 here match the best. So what we're going to do now is we're going to weld these onto our grater bit on either side. We're going to leave the middle ones off, and we'll show you what we're going to do after we get that done. But we'll probably just go with some good heavy tacks right now, not weld them completely. I got my little 90-degree magnet there. We're holding it back from the edge just far enough to get a good bead around there. And then we flushed it here on the back. We obviously squared it with our little tri-square to make sure we were square. So I'm going to go ahead and tack this one on. All right, we got both ends tacked good. They're nice and square. You can see there. We slid our toolbar through, putting the middle 2 uprights in as we did. We measured on both ends, made sure we had the correct amount. This was just over 5 feet because the original one was cut 5'3". So we left a little bit out here on the ends, which will be fine. So we're going to get this tacked up here now that this is square on both sides. And then we'll measure to see where our uprights go. We're also going to clamp a straight edge on the bottom. We'll show you how we do that. But we're going to get this thing tacked up first. So we got a big heavy piece of angle iron and clamped along the bottom of the blade, because we want this blade to stay nice and true, because as we weld, this thing will want to kind of bend around and move around on you, which may make your blade tweak a little bit. So that's why the straight edge. So now we're going to come and put these at 20 inches from the end, and we'll square them up, flush them on the back. We'll get those tacked in, and then we can start welding. We got everything tacked, 2 sides, front, back, all the way across. So now we're going to start welding this thing out. We've already made sure that these are going to fit in between our A-frame, which is very important. So every weld that I do, I'm going to do the opposing weld on the other side. So everything kind of evens out. So if I run this bead, my next bead will be down here. If I run this bead, my next bead will be right here, and so on and so on. If I run this bead out here, then I'll come run this bead out here. So everything is going to be opposite as I go. So this thing will want to pull around in the same direction. If it pulls one way, then it'll want to pull the other way. And then this thing should come out straight. When we take that angle iron off, you should see that it will be straight and true all the way across. Now, if you want to keep everything nice and clean and not get the little metal berries everywhere, get you some anti-spatter spray. You can even use it on your nozzle itself to keep the nozzle clean. But I spray it all around where I'm going to weld, and it keeps things nice and clean. You don't have to come back and, chip all those little berries off. So we're taking a little break. Whenever you're welding something that heavy and that hot, things get really, really warm. The welder needs to cool off a little bit. All the metal needs to cool down a little bit. I wore the wrong hat into the shop. I had to go get my dirty hat because I forget all the time and wear my good hat into the shop, and then I get greasy little fingerprints all over the bill. Terrible. But we took some steaks out for dinner and we're just chilling. So we'll get back after it here in a second. Look who decides to show up when the work's almost done. Brandy the Wonder Dog. What have you been doing, girl? You been out chasing rabbits? Huh? Always showing up when the work's almost done. Well, Brandy and I, we are headed to town. I ran out of wire in the MIG welder. So I'm going to use this opportunity to get those bolts that I was not going to have till tomorrow. And you know what that means? We'll get this thing working tonight, which is exciting. And I'll grab a burger while I'm in town. Sounds good. All right, we're back in business. Got a darn mouse bringing food in here. Need to clean all that out of there. Little stinker. We got the toolbar all welded, both sides all the way around. So now we're going to weld down here on the greater bit, and we'll front and back's already welded, so we just got to weld down both sides of each shank there. Now we're going to do the same thing. We're going to alternate weld. So if I weld this one on the outside, I'll do the outside one down there, and so on and so on. So we have opposing pulling forces. And then once that cools off a little bit, we'll be able to remove this angle iron. All right, we got the greater bit welded on. I welded all these uphill. That's why the weld stacked up a little bit more. To get more penetration going uphill like that. But this thing's pretty much all welded out. I'm going to just let this thing sit and cool. And while it does that, we're going to work on these swivel bolts for the toolbar clamps. So what we're going to do is we're just going to cut these shanks off of these eyelets here. And then we're going to cut the heads off of these black bolts. And then we're going to weld this to this. Now, if it wasn't so flippin' hot today, I could forge these heads down, make them flat, round, and then drill holes in them like those. But it's too hot today to be doing any forging, so we're just going to weld those. Got those heads cut off. We're just doing it with our little 4.5-inch grinder with a cutoff wheel. So now we're going to cut the heads of these bolts off. Now we got it welded on the other side, tack welded. We left a gap half the size of the bolt. So this whole thing will be welded all the way through. You don't want to just butt that up and have a weld around the outside. So this is going to be welded all the way through that bolt. So that baby's welded all the way through, nice and strong. So we can leave the weld on this side because it's not going to interfere with anything. But this side needs to stay flat, so there can't be anything protruding further than the sides of that ball there. So we'll sand this down real nice so that'll fit in that slot and not hang up. All right, there's the second one. Now you don't want to cool these off in water so you can handle them because you don't know what kind of steel this is right here, and you don't want to make it brittle. So let it cool off naturally, and you won't take the chance of turning that steel hard and brittle. While we're waiting for those bolts to cool, we're cool enough over here where we can pull this angle iron off, and we'll get this thing over on the tractor. When we pulled the angle iron off, didn't pop or anything, didn't move. You can see we are perfectly flat after all that welding. So let's get this thing put on the tractor. All right, this baby's on the tractor. Let's come over here to the side, see what it looks like. There she is. I got to rotate that quick hitch back. I had to rotate it forward so those clamps would stay open. But we'll rotate it back and we'll get these bolts in there and get this thing locked down. Looking good. Alrighty folks, we are done. Everything is all clamped up nice and tight. This thing's ready to try. I can't wait to get it out here in the driveway and get it down in the dirt, see what she does. Alright, camera died, so we went in and cleaned up and let the camera charge a little bit. So you could probably tell I wasn't being too aggressive, and I didn't go very deep with that hoe because that's all I wanted to do. I don't want it to go real deep. I don't want to move a lot of dirt. I just need to skim the surface, and it worked phenomenal. Now I can go deeper. All I got to do is lower that 3-point just a little bit more, and it'll dig more dirt. Or if I wanted to go a little more aggressive, all I got to do is shorten the top link and cause that blade to bite a little bit more. So it works great though, folks. It did exactly what I wanted it to do. Now, I could even use that in the garden if I didn't have a deer fence to deal with. I could do the walk paths in my garden, one sweep with the tractor, and I'd be done. Now, I wouldn't want to get it like out here in like a big grassy area, or you know, where grass is like this thick, because all it's going to do is ball up on the front of that thing. Maybe someday I'll try it, but I don't want to bend the darn thing. It does exactly what I need it to do, as long as I don't hit a tree stump or something like that. It's not going to get all bent up. I didn't do over here because I just weed sprayed all this, and I want those weeds to die real good. But we did right here, and it did exactly what we wanted it to do. You see a little weed there. It's loose. Kicked it right up. So I hope you enjoyed today's video. I know it's kind of a long one, but it takes a while to get that stuff done. So until next time, stay safe, stay healthy. We love you guys. Come back and see us here on Mark Kelly Farm.